Hello everyone. Welcome to the ninth part of Modeling, Analysis and Design of PEB Structure. I am Surajit Ghosh, and in this session, I will discuss about different types of load required for analysis and design, how to create these loads manually with proper load type and using a sheet file. I will use the same PEB structure with tapered column and rafter. To know more about this model, or different specifications like member offset or beta angle, you can check the complete playlist. Link is provided in the description. We have already modeled the basic structural components like column, rafter and purlin, which carry and transfer the load. Few components like roof or side panels, sag rods are not considered in the model, and we will apply the load coming from these components directly on the structure. Along with that, there are several additional loads like crane or machine load, which must be considered for design. We need to assess all the external loads acting on the structure and accordingly generate the primary load case. For any pre-engineered building, there are few loads which are common to all type of structure, whether it is a warehouse or plant unit, and few additional loads which depend on the structure type, location and usage. Let's check all these loads and corresponding design guides. First, the gravity load, which we can further categorize as dead load, which comes from the self weight of the different structural and non-structural components. For Indian standard, we can follow IS 875 Part 1 to calculate the dead load intensity, and for American standard, we can follow either AC7 or MBMA code. Second category is live load or imposed load generated from the use and occupancy of the building. We can use IS 875 Part 2 or AC7 to calculate this. These two loads are common for all types of structure, and load intensity is not dependent on the location. In any manufacturing or plant unit, medium to high capacity cranes are used, and it is very important to consider the crane load during analysis and design. Though it is nothing but a dead load of the crane unit plus maximum load capacity, still we don't consider this along with structural dead load. Crane load is not a static component. It moves along two horizontal axes, and depending on the location of the crane, load distribution and bending profile change. That's why we consider this as a separate moving load case and combine this with other gravity loads using proper load combination factor. If there is any machine or equipment placed on an elevated floor or connected to a structural component, we need to consider that load along with other dead load. Either we can add the load directly under primary dead load case or create a separate dead load just for the additional loads. If there is any dynamic component like effects on the structure due to machine vibration or operating condition, that needs to be considered separately using a time history load. If the structure is located in a dry area where the change of temperature is extreme, we need to consider the temperature load during analysis as suggested in IS 875 Part 5. Difference between maximum and minimum temperature generates an additional stress in structural components, and we need to design the structure in such a way that all members can withstand this stress. There is another load which is relevant to the structures in a dry or industrial area like steel or cement plant: dust load. Over time, dust is accumulated on the roof and structural components, and this imposes an additional load on these elements. Though the intensity is very small, still we need to consider this load for analysis. In IS 875 Part 2, few information is provided related to the dust load. For more details, we can consult AC7. When the structure is in a hilly area or an area which is subjected to snowfall, we need to consider an additional load due to snow. We can follow IS 875 Part 4 or AC7 to calculate the design snow load on roof or any other area which is subjected to snow accumulation. This 3 load depends on the location. Also, there are few other loads like hydrostatic and soil pressure load, fatigue, construction loads, which are case specific. That's all about gravity load. Next is lateral load with wind and seismic component. For wind load generation, we can consult IS 875 Part 3 2015 or AC7 code. Though a wind load generator is included in STAAD to auto-generate wind load on different parts of the structure, it is not extended to sloped or pitched roof structure. So it is not recommended to use this option for PEB. We can manually calculate and apply the load on the structure or use some custom macro. Finally, we need to consider the seismic load following IS 1893 Part 1 and 4. 1 is for general building and 4 is for the industrial structure. Either we can apply the load as static seismic load or use dynamic load. Our model is quite small, so we can use static seismic load. But for large structure or a structure which is located in a high seismic prone area, proper dynamic analysis using site-specific response spectra or time history load is required. That's all about the required loads which we need to consider for analysis and design. This is just an overview. I'll cover all the loads in detail. For this model, we'll consider dead load from structural and non-structural components along with dust load, live load, wind and static seismic load from two orthogonal directions. As this structure is symmetric, we can ignore lateral load from -x and -z direction and consider this in the load combination. For irregular structure, load from positive and negative direction might have different effect on the structure. So we need to consider lateral load from all orthogonal directions. Next, I want to discuss how to generate these loads in a model and what is the correct order. There are two methods to create a load case in STAAD. Either we can create a primary load case for each load type or create a reference load case, which is not used for analysis. For a large structure with several loads from different machine, plant unit or equipment, it is better to create separate reference load case for each item and combine those in a single primary load case. This is a more organized approach and we can eliminate the analysis result of isolated case. For this model, there are only few loads, so we can use primary load case. For more details on reference load case, you can check my previous video on reference load. In this model, I have imported all primary load cases from a seed file, which I have covered in part 2.1. During model generation, a seed file is used which contain all primary load case and load combinations as per IS 800-2007 code. It is very easy to work with a seed file rather than copy-paste the comments from an old model. If we work with similar type of projects, some part of the model remains identical, like load case and combinations, section information or design parameter block. We can easily create separate seed file for each scenario and use that in any new project. Seed file is nothing but a blank STAAD model with specific information. For example, check the seed file which I have used to import load case. This is a STAAD model without any geometry or other comments. Only several blank load case and combinations are present in this file. We can confirm the same from the input file. As we can notice here, except loads, no other information is available. When we import this file as a seed file, only these comments are imported in the new model. If we want, we can add more information in the seed file. This is the final model with all primary load case. First two are the seismic load case for X and Z direction. Static seismic load must be defined before any other load case, else during analysis an error will be reported. For dynamic load, it is not mandatory. This is followed by a dead load, live load, and two wind load case for X and Z direction. I will add the dust load under same dead load case. For now, ignore the combinations. I will discuss this later. One important point about all this load case is the load type. Instead, load type is not mandatory, and we can create a primary load case without any load type. It can be used for analysis and design, but if we want to use load generation features like mass model generator or auto load combination, then load type is a must, and without proper type, generated loads or combinations will be incorrect. There are several useful load types present in the dropdown. I always prefer to create a primary load case with proper name and type. If required, we can cross-check or change the load type easily from this option in the load ribbon. That's all for today. In the next video, I will discuss about dead and live load. Also add different load items in the model. See you soon.